Right, good afternoon and welcome. It's fantastic to have a full room here. I'm Will Law from Akamai, and welcome to OpenMOQ and MOQ session. Special thanks to Dan for making this an actually open session so that anyone could come in. There's a lot of interest in MOQ. We have a super full and packed agenda for you today, so let me summarize what's going to happen. We're going to have a few slides just to set a baseline. There's a lot of uncertainty and doubt about what MOQ is, so we're going to give you a little bit of information. We're going to show you some very brief demos so you can see the sort of things our panelists are working on even as it's being developed. And then we're going to go into the panel session. I have 2 prepared questions for every panelist, and at the end of those, then we're going to go straight to audience questions. If we run out of time, we will definitely continue the discussion upstairs on the 3rd floor. So let me not waste any time. What is MOQ, right? MOQ is a pub-sub protocol running over quick transport. It's been developed over the last 4 years at the IETF, and it's often called media over quick, but notice I'm not using the words media over quick because it doesn't have to be media. MOQ is a data agnostic protocol. It can move all kinds of data. It's very good at moving media, but it can move other things as well. There's a lot of text on this slide. These are some of the core technical benefits: parallel streams, tunable latency, priority control, cache support for scalable distribution, end-to-end encryption, multi-directional data in every single connection, a single protocol for contribution and distribution. Now, you may not be engineers in the audience. What fraction of the audience are engineers here? Okay, a fair bit, cool. So we actually could have gone deeper.
Let's geek out.
So we can say there, for the people who didn't put their hand up, why do you care, right? What are the benefits you get out of this? You get a quality of media, you get very rich and personalized experiences in your media players, the next evolution in media distribution. You can reduce your distribution cost for real-time streaming. You can improve scalability by being able to cache real-time content, flexible deployments, and a common protocol stack. So what is OpenMOQ? OpenMOQ is a software consortium. It's a group of companies and individuals getting together to write software. We're not an industry forum. We're here to write code and develop code. It was founded just a few months ago, and these are the companies, these are all the members. The founding members, the charter members, are the ones on the stage, and that's why we have everybody here. But we have other members as well who I want to give credit to, and many of whom are in the audience here today. Why did we do this? Right. Streaming, in case you haven't noticed, has become a commodity business, right? A new technology such as MOQ has technical and business risks in introducing it. So to minimize those risks, we want to share the development cost. The financial and risk is lowered when multiple people get together to collaborate on building something. We want to catalyze this next evolution in streaming, and we want to pool our expertise to create really good products, which we then go off and use. So there's competitors in MOQ, and we will compete even though we use the same software. We want to democratize as much as we can innovation behind MOQ. That's our reason for being. Some quick, pun intended, demos, okay?
Hey, Cullen. Hey, Mo.
Ooh.
Welcome to the MOQ demo.
Down.
Cullen, why don't you start us with introducing MOQ?
So MOQ allows us to get the low latency that we need for real-time video conferences like this. Mo, you want to tell us a little bit about the features we're using here?
Demo.
Sure, yeah. There's actually a very new feature that enables us to replace very complex app servers with the simple relay network, and it enables really complex technologies like this active speaker switching. So you should see ultra-low latency switching as new users join. So for example, let's try to bring Vanessa in and see how fast she switches in.
Yeah, sure. Just to talk a little bit more about latency, latency really disrupts the natural rhythm of conversation. So when you do have a significant amount of latency, that will hinder smooth talking, turn taking, which then increases this kind of cognitive fatigue because people are really trying to work on processing their social cues. And so this all ultimately leads to more misunderstandings and broken down communications.
Cullen, do you want to wrap up what we saw today?
Sure. So, I mean, it's great to see MOQ's at very early stages right now, but even where we are today, you can already build video conferencing applications like this that have lower latency than most of the WebRTC calls I'm on.
Cool. Thank you, everyone.
So that was a longer demo. You can talk to Cisco more, but that is Cisco's next-gen client, a prototype that's running completely over MOQ, over a commercial CDN as well, which is next generation of media. Now, this is a player built by Red 5. It's literally called Player. There's a whole suite of players available right now, but this is one that's coming out in order to play back MOQ on the client side. Night of the Living Dead making an appearance. It could be the new Buck Bunny. Okay. Now, the rest of my demos, that one's cut off, but we can see enough here. They don't have audio. I'm going to talk over them, right? This is Akamai, that's Peter, and he's in the new Cisco JavaScript-based web client running over MOQ in a real-time conversation on Akamai network. And that's Michael from CDN77, and he's in Europe running over their network, but we're able to discover content on each other's CDNs, which is something you can never, ever do with HTTP today. It's a real-time web conferencing on 2 different networks, but with discoverability in between them. And that is something new for CDN here. This is Gwendal from the Nordics. They have a production pipeline with MOQ already in, both for contribution. This demo is running at 100 milliseconds of latency. They have CMAP support, they have encryption, they have statistics, they have very impressive, and they have real-time captions and text. Again, MOQ is multimodal. Some early stats from Gwendal on deployments here compared to their existing solution, which is WebRTC-based. 44% faster time to first frame, 13% less buffering, and 80% player support. Because MOQ can run over Web Transport's now available in all 3 major browser code bases in full production, so we have an easily accessible surface of test clients. This is a collaboration of the 4 companies' logos shown at the bottom. It's showing a real-time basketball game that's being indexed in AI. You can scrub back into the real-time stream because we're caching the real-time content, watch the subclip while other consumers are still watching the live stream. So you have an ability to do rewind and subclip generation in very low latency streams. Latency here, 680 milliseconds for this game. This is from a TEM. They've hooked up their Titan encoder. Sorry, it's very geeky quad panel here, but the Titan encoder is publishing to a local MOQ relay, which is then pushing it into a distribution network. And on the bottom left, they've updated Sharka Player and done the work because Alvaro is now a maintainer there, and they're able to play back the content. This is using a version of the MOQ streaming format, showing off surround sound while they're at it and more low latency. This is a demo from Synamedia about ad insertion. You can see it down on the show floor. They're queuing up the various components of the ad system here. They're going up and selecting an ad. It's important that MOQ can leverage existing ad inventory and that we are able to monetize these solutions. Same player as the last one, but now instead of the subclip, it's going to generate the ad. So this is a test interface. We see the ad. The actual production will be a smooth cut, and we're still doing a lot of work on ad insertion, but all the basics and foundation are there for MOQ at the moment. You can't get excited about the flashy player side. When we talk about networks, this is a deployment that Akamai's done of MOQ relays around the world, and we're starting to build out the tooling, the boring stuff, if you will, to monitor it, to be able to go in, check the Spectre, get logs in real time, debug it, and run conformance tests, because a large part of standardized development is making sure that everything's behaving as it should do, and that we can get reliable and deterministic performance across a whole suite of relays. So a lot of work being done there. And then the question you're most concerned about is MOQ compatible with Big Buck Bunny? And the answer, of course, yes, it is. We can stream it. We stream an awful lot of Big Buck Bunny, and just like these guys are finding out, there's some very interesting thing coming to knock them into the future here. So some takeaways, I'll give it to you up ahead. There's a QR code. You can go get the relay that's being built. The relay is the core server product. It's free. You can use it. It's open source. And you can go to all the companies here and see additional demos for MOQ, and there's a QR code. I have my panelists. They're an esteemed panel. We're not going to spend time going through introductions on each one. So I'll just ask you, when you answer your first question, just say who you are and where you're from, and everyone else can read it on the screen at the same time. And I will sit down and get out of the way. First question is to Chris. Yeah. Sit down, Will. Red 5 has long focused on real-time interactive streaming. From your perspective, what does MOQ enable technically that existing approaches like WebRTC and HLS struggle to deliver?
Yeah, this is a great question, and I think you did it. We're known for doing real-time streaming, so I don't even think I need to explain what Red 5 does. The reason we really got into this MOQ stuff is because we were basically running 2 parallel stacks, right? To be able to do things like DVR scrubbing for recording, for other things like that. WebRTC works quite well for real-time video, and especially like video calling, and when you need to do noise suppression and echo cancellation, those kind of things. But to scale it was, I mean, one of the greatest hacks in the world, you know, building out this cluster of servers to be able to then deliver the video in a peer-to-peer manner. Unfortunately, we had to use cloud VMs, which then the egress cost coming out of that stuff is pretty high. So we're really excited about the future of collaborating with CDNs like Akamai and CDN 77 and others in the group, as well as CashY. We're working actively with deploying relays to be able to move that stuff out to the CDN, let them do what they do really well, let us do all the kind of conversions and interactive experiences on top of it, and then we've got one protocol that allows us to do all of this, which is incredible.
Great, thanks. Second question, Cullen, Jennings, Cisco. You've been building real-time communication systems since the early days of VoIP. What lessons from that world influenced the design of MOQ?
Yeah, I think that was really important that we could build on a lot of those things. So the first things that Cisco had been really involved with and I helped drive a lot was SIP, where we were getting over 1 billion minutes. You know, it was one of the first internet protocols for voice and video that was doing over 1 billion minutes a day. And that, we really learned how to get low latency. And a big part of that was moving to UDP packets, where we had a lot more ways to deal with loss and congestion control and problems and hiccups that happen in the network, versus TCP, which sort of gave us one way to do it. And I think we bring a lot of those lessons forward into it. After that, sort of WebRTC really helped move up the bar with dealing with a lot more use cases than the sort of phone calls and video conferencing that SIP had sort of nailed. But that, with it, brought a lot of complexity, and it brought not a lot of ways. It tried to isolate the feature and tuning away from it. I mean, the browser does what the browser is going to do, and the app has to sit on top of that and work with that. It was never really designed for low-cost optimization. So I think that what we really tried to do with bringing those design experiences into MOQ was bring the good parts about the low latency in, bring the scalability designs that we'd seen from HLS Dash and those types of things in, and bring the ability to really reduce the complexity of the applications and also allow the applications to tune for the specific environments they were in, while at the same time bringing the whole cost down. So for us, at Cisco, we're really sort of focused on these video conferencing experiences that are often customers are very demanding about security or quality, and they want to make sure that that isn't compromised. And at the same time, we're constantly trying to reduce our costs. So this was a really powerful model to bring all of those together at once.
Thanks. Next question for Sean, for YouTube. You are interested in driving forward the ingest side of the protocol. Why is this, and what are the aspects of MOQ that are appealing for ingest and contribution?
Cool, thanks, Will. Yeah, so live is really big on YouTube, and it's growing. It's sort of one of our fastest growing sets of content. And we essentially have two types of live content that we see, what we call endemic, or UGC live, and OTT. And at first, when we started exploring MOQ and really getting involved in IETF and defining the spec early on, it was with the endemic use case in mind. So today, if you go live, a creator goes live on YouTube, almost all of that video acquisition is done via RTMP. Mm-hmm. And there's a lot of shortcomings to RTMP. So much so that we're actually, we're keeping the protocol alive through enhanced RTMP, through a software group called VioVera, where we're basically adding new features and functionality to continue supporting it. But the basic shortcomings include, it's not protocol agnostic. We want to take advantage of new codecs. There's latency concerns. There's concerns with just general performance under bandwidth-constrained networks. But surprisingly, it was actually the OTT use case that really had us double down and commit to OpenMOQ. And the main driver there was trying to meet rather than meeting our content partners where they are today with their linear distribution, so think, satellite distribution, fiber, direct fiber multicast transport stream distribution, or even, SRT, and these, OTT acquisition formats. There's inherent latency in satellite. That, you could shave seconds off on the delivery side on the CDN, but you can shave, tens of seconds, 20, 30 seconds off if you replace an IRD. There are known quality issues and reliability issues with SRT. So we're trying to rally the industry, working with partners like ATEM and like these other OTT broadcast encoders to support MOQ outputs, everything from the multi-track feature set where we can prioritize primary audio. If there's 8 audio tracks, we can prioritize the ingestion of the audio that's going to be viewed by the majority of our audience, to just the tunable latency aspect. We're seeing that use case really help drive down our physical infrastructure costs. We want to get out of the physical infrastructure world, out of the fiber world, and there's been slow adoption to SRT. So we're pivoting our focus now to innovate with content partners on MOQ.
Thanks, Sean. Next question for Gwendal from Synamedia. You work closely with broadcasters and operators who rely on stable, proven workflows. What technical capabilities in MOQ could realistically improve the way broadcasters deliver live video?
Yeah, so it's broadcasters that don't go to internet because they want to rebuild the grandpa's TV. They want to build something which is much richer. They want to have much more information transported in the video. And when they build this primary distribution, when they have to reach these 1,200 affiliates all over the US or all over the world, they want to have personalized delivery so that you can have a different audio for West Coast and East Coast when there is a Lakers against Celtics game, when you will have different audio and different subtitles that will be delivered based on the delivery and based on what is the community that is served for this TV. And MOQ is offering this. MOQ is offering a way to scale the content as well as scaling the delivery, so you can have as many tracks as you want, and the broadcasters can offer all these tracks, and it can say, hey, help yourself, dear affiliates, and you can generate your own TV feed, which will be personalized TV feed. And this is something which is very new and which will bring much more value for the broadcasters and the service operators. And so this is why we want to help them to do this.
Great, thanks, Gwendal. Next question for Arvind from Oracle Media Services. From a cloud media infrastructure perspective, how could MOQ change the way media workflows are built and scaled in cloud environments?
Absolutely. Thanks, Will, and for the opportunity to talk about MOQ. I want to take this in a couple of ways. First is when you look at large-scale live events. Traditionally, the cloud environment is great at hosting your live workflows, right? This is your ingest, your encoder, your packager. But when it comes to delivery, typically it goes into a fragmented ecosystem. So our customers constantly talk to us about this is, what could we do as a cloud provider that gives giant easy buttons for the delivery aspects to also be well managed? And for Oracle, that's really exciting because with MOQ, we're able to containerize MOQ and actually conceive a fleet of MOQ relays that are deployed across our cloud regions, for cross-cloud bit movement. But beyond that, we can also have the opportunity to extend those containerized environments outside of OCI's network, whether that is deploying it into a CDN POP or eventually even into a residential network. And that is really exciting for us because that gives our customers a consistent way of aggregated capacity that they can have access to. While at the same time, we are able to foster a rich ecosystem of vendors that we can work with. So it's almost like a one-time effort in terms of setting that up actually reaps repeated benefits. Contrast that with all of the multi-CDN implementations that happen today. Content steering is the same problem is being solved repeatedly. So this gives us a real meaningful way to really influence delivery without the cloud and a provider really becoming a CDN. And so that's actually a key distinction that we want to make.
Great. And the next question for Thomas, CDN 77. I understand why application developers care about open and interoperable standards. But from the perspective of an established CDN, why should companies like CDN 7 invest time and resources into building an open ecosystem around MOQ?
So from our side, it wasn't just spreadsheets and numbers behind the decision. I personally believe that standards, well, at least internet standards, are a good thing, and that the fastest way to their adoption is through open source ecosystems around them. In the long term, it should also make the lives of our clients, well, and our lives as well, easier. You know, any standards speed up the integration and remove engineering waste. At the end of the day, any vendor lock is just a costly illusion. So if OpenMOQ is to streaming what, for example, Nginx was to the web, then I'll much rather participate in the design phase of it than later spending time and engineering hours by patching it to match our use case.
Well said, thank you. Now we're back to Chris, Red 5. Low latency is already achievable, right? But delivering it to very large audiences remains challenging. What type of new applications could realistically emerge if MOQ becomes widely deployed?
Yeah, I mean, we've been seeing emerging stuff for a while of this kind of interactive TV. I mean, Gwendal already mentioned one where personalizing the live experience with multiple tracks. I mean, that's something that you don't really get with WebRTC. You have to like actually switch the stream. We have this like interstitial kind of mode where you can shove something into that RTP stream coming down to the client, but it's not as dynamic as being able to just pick a track and go into it like that. And then just like, it's a lot of work to create your own, massive size WebRTC distribution. We have other competitors who've done similar things to us, and everybody has their own thing. They try to build this WIP and WEP, which does work, but nobody has really taken that protocol and made it interoperable amongst all the other vendors. And I think what we're seeing here with this, especially like Akamai being a participant, CDN 77, we're working with CashFly on this. All these other CDNs are getting involved in something that is going to allow us to really create massive distribution. And I'm not getting back to your question. What are the user experiences, right?
Yeah.
But this is important because now it allows us to do these massive scale things. Something like streaming the Super Bowl over this now is possible because we have multiple CDNs who are going to be able to support it. And then we've got multi-directional stuff where then things like talk radio, but with video. So people can join with their phones, jump into the live stream, personalized experiences and switching between different tracks. All of these things that I think are going to be coming up. Obviously, sports betting is a pretty obvious one. But the list just goes on and on. It's a lot of the stuff we've already been doing, but just kind of at smaller scale. And I think we're now at the point where this is going to start to get really big very quickly. And I think that's a part of the motivation for YouTube, too, is to see this level of interactivity. Yeah.
Okay, next question for Cullen. Moving from an RFC, which is the document that comes out of the IETF, to real deployment is always hard. What has to happen across network vendors, infrastructure providers, and operators for MOQ to become part of the internet's media delivery fabric?
So thank you, Will. I spent a huge amount of time thinking about this. As we've taken, most protocols done as standards don't actually deploy in any real way at scale. So I spent a lot of time thinking about what is the ones that made SIP work, made WebRTC work, will make MOQ work. And I think the thing that I think about first is who are all the players that need to do something for this to be, and who are the users and customers of all of this? And is there food on their plate? Is there a compelling reason for every single one of those to deploy? So for years when we talked about this at Cisco, we're like, wow, this would be amazing for how we could build out our application, but we need a CDN vendor to be there first before you do it. And you have this chicken and egg problem that you're trying to break out of, right? Of the CDN vendors don't want to do it when there's no app, the app vendors don't want to do it when there's no CDN, all that. So we need all of that to come together, and it takes blind faith at some level that there is going to be some customers that make sense you're going to build it. But we need the people deploying the relay networks. We need those to be widely applicable, or widely deployed and high quality and work well. We need multiple applications to be building out at the same time. And there's a bunch of things that we can do to enable that. Part of it is the standards work itself of having an easy and well-defined standard that actually, if you implement it, the stuff works together versus like, oh, there's a million options and we all implemented something that was the spec, but it doesn't work together. And then you need the next level of getting message out and people understanding the use cases for it and how they would use it. Sessions like this, thank you for making this type of thing happen where people can understand and figure out who's doing it. And then the next thing that really needs to happen is driving very much the software. And open source really helps drive it. It's not the only way. And it's sort of funny, some of the companies involved with this are doing their own proprietary implementations and are also doing open source implementations because they see the value of having multiple things and driving interoperability through that. So that helps drive it a lot. And then finally, it'll be, delivering customer value where it really improves the user experience and allows you to do new applications you couldn't do before. When we bring all of those things together, you really just have this, compounding magnification effect that's hard to stop. And I see every one of those things happening right now for MOQ.
Okay. Thanks. Next question for Sean. Large platforms often build highly optimized internal systems. YouTube's famous for being vertically integrated. So why should a hyperscale platform care about the success of an open protocol like MOQ? You can make your own.
No, it's a great question. And it's a question that we have to answer to our leadership. Why are we here? Why are we joining an open source consortium and leaning into a protocol when we can really do this in a closed ecosystem? I'll start with quickly talking about one of the reasons we aren't, but others might. And then I'll get into the reasons we are. One of the reasons we're not is for the interactivity. So we have interactivity, and we have interactivity working really well in our apps. It could be everything from on the OTT side, the way we highlight key plays based on data. It could be chat interactions with creators going live. We've built all that without MOQ. But it took a lot of work, and it took a lot of proprietary Google and YouTube hardware and software to do that. If other platforms want to make something similar, MOQ is the logical way to go. It democratizes, these sorts of rich features that are otherwise really difficult to build or very time-consuming with engineering resources. Now, that said, even on the playout side, we're highly optimized down to the kernel level for HTTP delivery. But we have a lot of quick delivery. So any quick adoption in the industry is actually good for us because we get more data, we get more interoperability with quick. So it actually helps us, even though it's not necessarily MOQ. But the real reasons on the ingest side, or shine on the ingest side that I was talking about earlier are helping our content partners better scale. So fan out, for instance. When we're comparing SRT capabilities to MOQ when it comes to, partner distribution for a content company. So if you're a Disney or a Warner or a Fox and you're, distributing to multiple platforms, and your cable providers, your MVPDs, your Hulus, your Slings, and all of these platforms, you're gonna have to set up a unique SRT stream. And that doesn't scale if you have hundreds of linear channels and you're going to, tens, 20s, dozens of these partners. MOQ provides fan-out capabilities so you can set up one MOQ stream, we can subscribe to that pub sub, and we're helping our content partners help ourselves, right? Or we're helping our content partners and helping ourselves. They're not bandwidth constrained. We have a stable relay that's delivering fast, high-quality media. Everyone wins. The other option is we have to build out these private line fibers or trust, that their internet bandwidth can handle many, many, many SRT streams. And we've seen quality and reliability issues there. So, those are the two that really come to mind. But in general, I guess one other thing, if I could. Our other option, if we didn't lean into a MOQ ingestion library or a contribution library, is create a YouTube library. I'm not going to name another proprietary protocol, but those exist, and there are benefits, and there are reasons why we might want to do that. But we're not in the first-party encoding business. Yes, our app has the go live button, and we have our own code there, and we are going to put our own MOQ implementation there with some YouTube secret sauce around it. But we want to integrate with the Atems of the world and the Bitmovens and the Harmonics and the name your OTT, encoding vendor. One of our first projects actually in the ingest working group for OpenMOQ is to do an OBS implementation. We get a lot of creators using OBS. Right now, the OBS output to YouTube is ERTMP. We want to have a qualified version integrated with OBS that's not YouTube proprietary per se, but we know will work well with our ingestion service.
Thanks, Sean. Over to Gwendal. So we've got 3 more questions, then we're going to go to audience questions, okay? Gwendal, operators are naturally cautious about changing infrastructure. What would need to happen for them to see MOQ as an opportunity, not so much as a risk?
Backward compatibility. So most of the, all the affiliates, all the MVPDs, they have very robust video header technologies running. And so they will not change this just because MOQ. So what we build is something which is, we want to provide all the MOQ features, all this multi-track management, all this management of very rich information that you can share, all the metadata that you can have, all the AI stuff that we'll bring. And we want to maintain MPEG-2 delivery, because most of the affiliates, they will continue having MPEG-2 downstream to the end users. And we want to maintain SCTI certified for all the blackout management, all the ad insertion. So this is something that we bring to MOQ. So in OpenMOQ, we build the software, and in the MOQ working group at IETF, we contribute by offering this way to interact MOQ with all the other technologies that all the broadcasters are used to deploy and used to enjoy every day, and to have a constantly ongoing TV channel which just works and delivers the stream what it goes. So backward compatibility is very significant, and so having MOQ-2 and MOQ-2 and MOQ-HLS and SCTI into MOQ, this is very significant.
Great, thanks. Arvind, cloud providers tend to accelerate adoption when new technology become a part of their platform. What role do you see cloud infrastructure playing in bringing MOQ into production environments?
Absolutely. There's a sizzle and the meat and potatoes parts to this response. What our customers find attractive is having an interoperable environment, right? Having their favorite vendors that they bring alongside as they adopt onto the cloud. But what the customers stay for is the operational discipline, right? And being able to manage a tier 1 service. That's really what matters in moving from a demo phase over to a fully production environment. And so to that end, I really feel like the meat and potatoes part of that story is where we have to work with our networking groups in partitioning our network in a way where video workloads don't opportunistically compete with general purpose workloads. Whether that is prioritizing DSCP marker packets over, and not deprioritizing UDP packets for that matter. Or whether it is having the right notification mechanisms so an always-on channel doesn't suffer an outage because an engineer took down a network card. So I really feel like there's 2 aspects to it, and an environment that's successfully handling both of that, creating an ecosystem where vendors can bring the products that they work with, as well as have the operational discipline in maintaining a highly available network. That really lowers the barrier for our customers to be able to scale to new geographies, or scale to new peaks, or even scaling to new content types.
Awesome. And so the last prepared question goes to Thomas. Low latency live delivery adds complexity and cost compared to VOD. So why should CDN see enough value in this space in order to invest in technologies like MOQ?
So first of all, we don't get to choose how people use the internet. We're one of the tools to help them do it, but we don't set the direction. I will agree with what Sean said. We see a clear path with live being more and more popular. We see it with the user-generated content platforms that are exploding with it. We see shifts in the sports rights towards streaming platforms. We see live commerce becoming a thing, and so on and so on. I totally agree that life is more challenging, but that's exactly why it makes sense to me to invest in new technologies around it. With MOQ, you get things like publish, subscribe, or a relay that actually understands the data. And from our CDN perspective, I can see clear benefits just from those two features alone. Also, life is where you prove your stability. Life is where you prove your routing, your direct capacities, your software, your everything. If a client can trust you with a large-scale live event, they know that they can trust you with anything else as well.
Excellent answer, thank you. Right, so that's the end of our prepared questions. So now I hope we have some audience questions. Thierry's sitting right in the front here. I'm sure he's got something. So if you have a question, raise your hand, and we'll be happy to answer it. Monsieur Fautier? Is there a mic, Dan?
Here, throw that.
I can't move because I'm tethered to this mic. Probably good.
Okay.
Keep Will on a lead.
Thank you, all of you. So one question which has been started over LinkedIn is about the scalability of MOQ. I know the servers need capacity, they need fan-out networking cards. And maybe a question for you, Will, and for CDN 77. When do you think there will be a tipping point where people will be more attracted by MOQ, not only for the interactivity and the multi-track, but also from scaling the internet? We heard the NASA people very happy about 50 million concurrent sessions. The Artemis 3 will be around 250 million plus.
I can give a real quick answer there. So a gigabyte out is a gigabyte out, whether it's over MOQ or not, it's still a gigabyte. And when they land on the moon, there's going to be a lot of traffic. MOQ has very low overhead compared to TCP. If I'm taking a video codec and I'm sending out an amount of raw payload data, MOQ has a very clean and lightweight encapsulation compared to TCP. So there will be some fraction lower than that, right? But it's going to take scalability. The challenge for MOQ, to be honest, today, if you're comparing MOQ against HTTP3, which is using QUIC as a substrate, they're almost identical for cost and performance. If you compare against H1 with TCP, you've got NIC offload, so you've got better performance there. So I'm of the firm belief that we will get QUIC-based NIC support in the future, and we will plan our business going forward for that for H3. And then I think you're going to have very similar parity. And then it's not so much a performance and scalability, it's the feature sets that are really attractive about MOQ and the bidirectional nature. Thomas, do you want to add to that?
Said it all. I don't have it.
Okay. Next question was here in the front, and then there was one at the back there. Terry, do you mind handing the mic around for us? Yes. That would be great.
Hi. Oh, thank you. My question is, what's our current status quo for this MOQ? So does OBS already support it? And how about our browser support it? And if we want to shift to what kind of, how much effort for our applications, just like to, you know, how accept the learning curve, but also, you know, what's the library or what's the plan in the roadhead? Maybe next year it should be very mature or stable, and the performance is ready for us to deploy it.
So on the browser support side, it's pretty universal now. We were waiting for web codecs to be added to Safari, which they just did. And that was one of the biggest blockers for it. And so you can roll your own player, but our goal, at least with Rep 5, and we're very active on the player side of this, is to make it an open source player that you can just take and use. And then that kind of covers the web, browser, both mobile and desktop. But then we're quickly moving into building native players for iOS and Android and everything else so that other people can use it. So I think you're going to have pretty widespread adoption of it. But I think one thing that's really important to note is that you don't have to go all in on MOQ, right? If you have smart TVs that just simply won't do it, just send them a low latency dash stream or whatever is going to work for that. And then you send the other stuff over MOQ when you want to have something a little bit lower latency or better interactivity for those experiences. I don't think it's an all-in on, you have to have everything ready for MOQ in order to roll it out.
Absolutely. So just to... Sean was going to answer.
Is this working all right? You guys hear me?
Yeah.
All right. So in regards specifically to OBS, I believe there is an implementation now from Luke. Luke Curley, I don't know if he's here. Luke, wave. Luke Curley? No, he didn't make it. Luke did an integration with OBS. So yes, the OBS supports a MOQ output. For the ingest working group, which may be kind of rebranded as a client-side working group, we might, decide to partner with Chris's, player team and just have a client-side, working group to share our code base for the pub sub of the stream. We have a set of ingest requirements that right now are not fully supported in every MOQ implementation, like in the current OBS one. So we're thinking about things first from an OTT perspective, which means we have to tackle issues like CMAF support, DRM, an interface for SCUDdy insertion to its own track. And these are things that our OpenMOQ ingest library plans on supporting. So it's in we're in the requirements gathering stage now. So we plan on actually having something by the end of the year for that.
Okay, so if now, just like that gentleman, he said, so we maybe do not deploy it at once for every aspect. Just like we have ingest, we have the output, we have viewer, but we also have our backbone, right? So maybe the first step it is I replace it just between our Orange server and Edge server. That's maybe the most benefits come from. Then we're going to just like deploy in the ingest or viewer side because they involved of the customer and broadcaster or browser. That's when we cannot control it.
Yeah, I think that's a very normal way for people to deploy is they're not going to do it everywhere once. They're going to pick a place that it makes sense for them to start, and they're going to move it for some of their clients some of the time in that place, and then incrementally move across it. And I think that that's a key property of deploying anything new is you have to be able to incrementally move to it. I mean, ask me about why IPv6 didn't deploy, right? It didn't have that property. This does, and I think that's a good way to do it.
Okay, can we just, Arvind had one more answer, and then I want to move to a different question because we got other people. I was going to say,
the train is leaving the station. You asked about status quo. You can actually go check out the fully working end-to-end pipeline and choose your own adventure to Cullen's point about where you want to start implementing it. But the end-to-end workflow is available right now in demo booths.
Okay, there was Terry with the hand on the left was first, and then second here.
Thanks, everybody. A quick question. I'd be interested in what your opinions are on the current status of client adaptive bitrate for MOQ. What's the support looking like? Is it going to be good? Is it going to be bad? Is it like MABR? What do you guys think?
I can answer this, but I don't want to answer all of them.
No, please go.
Okay, I'll talk. A lot of work being done on ABR, right? There's pure client-side ABR using a very similar bandwidth estimation as we do for HLS and Dash, timing the data and the receipt. We're also looking at server-side ABR. There's an open draft right now called dynamic track switching, if you search for that. And we're looking at bringing that into the MOQ transport, which is the core spec. This allows the client to ask the server on its behalf to switch on a throughput basis between a number of tracks. And that's essentially server-side switching. And then there's a third model, which is hybrid, which is where the server or the relay knows some information half an RTT ahead of the client, in many cases, about how the throughput's changing. It can communicate that information because MOQ's a bidirectional protocol to the client, and the client can then make enriched decisions for its ABR, but it's still executed on the client side. So 3 different strategies. The guys at Turkish University, Özgün University, have a demo up for ABR, and I would say ABR is one of the aspects that's most active at the moment in MOQ. We know we have to have solid ABR. ABR gets much harder if you're operating at 600 milliseconds. And again, I want to stop only talking about low latency for MOQ. MOQ works perfectly well at 15 seconds latency, and it does a lot of cool things at that level. So don't leave this room thinking MOQ's about low latency, right? That is one of the great applications of it, but there's many, many others.
Right.
Yeah.
And I'll extend onto that to expand onto AVR and talk more about QoE. You now have the ability to the bidirectionality aspect of MOQ to be able to aggregate metrics, and each relay point becomes a decision point as well. Gone are the days where all your decisioning are done in a centralized observability layer. Each relay can now decide for its cohort of sessions how it wants to manage the quality of it.
Yeah, and just to finish this, this is an ongoing conversation at IETF working group, and a very good conversation. And so we hope that we will finalize this this summer or close to this summer.
I have something.
Gwendal has a proposal called Switch, which he's shamelessly asking for support for, so please help Switch.
I also want to just point out that with Rep 5, we've had an ABR, I use it like this, implementation for switching over WebRTC for a while. And so we've basically taken that and done the same thing over MOQ. And we're not waiting for the spec. We'll implement the spec. Hopefully it is the one that Gwendal has set up. But I think that's another really important part about this, is that everybody can still move forward while we're waiting for this thing to get finalized.
Yeah, absolutely.
I know we stayed on this one for a while. Last thing I want to add. I think in one of the options that Will mentioned, a key aspect is what I would call configurability of ABR. So right now, a lot of ABR clients, or your iOS player, these are, you don't control the ABR logic. There's very little you can do. MOQ gives us an opportunity, I think, to change that paradigm. So, if you don't like the way your ABR algorithm is working under certain network conditions, I think it'll give you the opportunity.
You could create a streaming format where the publisher actually publishes the ABR algorithm it wants the relay to use on the client's behalf. That's totally doable in MOQ. We have a question.
Hey there. So we mentioned a lot about the features of MOQ and MOQ-T as well, and also the fact that MOQ is not going to replace HLS and Dash, and maybe in 5 years, maybe in 10 years from now. But I think a question is, we had that ecosystem running with Dash and HLS where we need manifest manipulation, origin packager, just-in-time packager, so a lot of different modules. What's the, in regard to those different modules, so we're still going to do SGAI, maybe not SSAI, but we're still going to have the need for some of the features we had on the just-in-time, on the origin packager, but what's the idea of the architecture? Like, are we going to have only like a relay and only an encoder pushing CMAF into the relay, and then all the relays are going to be like super smart and do all the things that we used to? What's the aim? Because
let me try to give a quick answer. We want relays to be very good at doing simple things and to do them highly deterministically and reliably. So if you look at the design for MOQ transport, the relay, it does simple things, but it's not doing any application logic. It's not mixing things, it's not changing things. Stuff comes in reliably, it goes out reliably, behaves in a certain way. So we envisage an architecture which is highly decoupled, where you have components that are pushing data in, and if something needs to change, a component will subscribe to it, modify it, and republish it into the network. And the relays are literally following the instructions of the publishers and the subscribers while honoring business logic that's been set for that configuration. So I think it's a very flexible structure. The relays give you the scale and the distribution, but you can easily plug application logic in to any node.
Yeah, you can mention MSF as well. So MSF is an attempt to build streaming platforms on top of MOQ. And the more we are building on MSF, the more we realize that the MOQ-T, the MOQ transport protocol, has everything to implement what we want. So advertisement is one, but the catalog manipulation is another one. The catalog is a kind of manifest. And we see DRM as a support as well. So, I mean, watermarking could be done as well with multiple track management. So all of this could be done. So it's just a matter of being smart to build this properly.
And it's tempting to take a either or situation when you talk about protocols, but it doesn't have to be, that doesn't have to be the argument, right? Your protocols can coexist. You cherry pick the protocol for the type of work you're doing. If you're transportation, you've got distribution use cases, MOQ can shine. But you obviously have to reckon with the realities of a fragmented device ecosystem. And if your players are not able to play MOQ natively, or it's taking its time to adopt, you figure out ways in which you can do HLS conversion at the edge. So the MOQ just gives you a set of Lego blocks that you can assemble together and build something that works for your customers.
MOQ's aim is not to replace HLS or Dash, to be clear. We all run businesses that depend on HLS or Dash to make a living, right? We are trying to bring new features out here. So if you do something in MOQ, it's because MOQ is great for doing that, it makes sense financially, it makes sense technically, and it's not something you can do with your existing distribution system or architecture today. If what you have is working for you, just stick with it. That's fine. Like, that's a better way forward.
The same thing for WebRTC. We're not trying to kill WebRTC either.
We're not, despite showing stats, right? WebRTC is fantastic. WebRTC is enabled. We take web conferencing for granted, right? We do it on our phones, we do it in hotels, we do it on airplanes. It just works everywhere. That's due to the ubiquity of WebRTC, which is another standard that took 8 years of people doing very similar things, and then a lot of grassroots efforts to try to implement it. Okay, we have time for 2 minutes, 16 seconds. Another question.
Wow.
Oh. Well, there was one at the back, and then in the front, and then that'll be it. Okay.
I'm just curious if you have any commitment from Apple and Android, Exoplayer and AV Foundation in particular, for playback on MOQ or other kind of key player platforms.
I don't think we need it, because they've given us all the tools in the browsers and everything else, and then we've got native code that we can write. So we're not blocked by it. Unlike WebRTC, where everything was bundled together, this is not like that. We've got web codecs, web transport, like all the pieces are there, and we don't need their blessing, I guess.
MOQ is a protocol that runs on top of QUIC or web transport. Yep. QUIC and web transport are supported in Apple, Android. Safari supports web transport now. They just released it last week, so it's broadly available. So it's really flexible. We can start building. We don't need the vendors to give us anything other than more optimal QUIC support, but that's good. Okay, last question here.
There are a lot of streaming protocols that have died over the time. I've been doing this for a long time. Why do you think that MOQ isn't the replacement for these things? I don't think that HLS is great. I'm sorry if anybody in the room loves it, but there's things that were better than that before, and it just happened to win because that was a good method for CDNs to deliver. Why not?
So firstly, MOQ is not a streaming protocol. MOQ is a pub-sub protocol for moving binary things. The streaming protocol that we use is called MOQ streaming format, MSF for short. So MSF is the MOQ version of HLS. And yes, HLS solved the problem. It solved distribution over HTTP networks. It lowered the cost. It did a lot of cool things. But we think we can do more with MOQ. We're not trying to replace HLS. And there's room for many streaming formats to run on top of MOQ. Ones that deliver media over MOQ, there can be many. And there can be other formats that don't deliver media. They deliver database updates. They deliver GPS coordinates. They deliver flight controls for drones. There's a lot you can do with MOQ that has nothing to do with media. And to do things over MOQ, you require another specification, which you might call a streaming format. So there's room for many.
And I think the other part is just all these companies, as you see here on stage, that are getting behind this. And it's not just us. It's like Cloudflare as well. I think there's a momentum picking up that's just going to snowball and make this protocol happen.
Absolutely. For every chair that you see here, there are plenty more that are not on the stage.
That's right.
That are doing really cool things.
Yeah. And then we've got AWS too. So I mean, it's getting crazy. So it's good.
So we have reached the end of the time. So I need to stop the questions, but I want to thank two groups. I want to thank the founders and the charter members of OpenMOQ. Thank you for your trust and your ability to collaborate. It's fantastic to keep working with you. And thank you all for the audience for coming here 4 to 5 during NAB talking to us. We are going to go upstairs and we're going to carry on talking about MOQ until they take the beers out of our hands. So thank you very much for your time today.
Thank you.